Lesson 2-3, Postulates and Diagrams. A postulate, otherwise known as an axiom, is a rule that is accepted without proof or is assumed. Now, they're good assumptions. They're based on logic and observations, but we can't prove them. A theorem, on the other hand, are rules that are accepted with proof. We use postulates to prove the theorems. All logic systems, all philosophies are based on postulates, which are assumptions, to prove everything else. You get in an argument with somebody, often you need to start with, what are you assuming? And then that'll fix most of your argument. There are several basic postulates, and you need to memorize them for a quiz that'll happen. First one, through any 2 points, there exists exactly one line. Next one, a line contains at least 2 points. So think of it this way. Here's 2 points. We can only draw one line through it, and obviously we can put 2 points on a line. Next one. If 2 lines intersect, then their intersection is exactly 1 point. So you have a line and a line. They intersect right there, which is 1 point. Next one. Through any 3 non-collinear points, there is exactly 1 plane. So if I have 3 points, the only way I can have a plane touch it is if it's flat on the screen. So 3 non-collinear points make a plane. The next postulate, a plane contains at least 3 non-collinear points. All right, if 2 points lie in a plane, then the line containing them lies in the plane. So there are 2 points on the plane of the screen. If I draw a line through those 2 points, it is also on the plane of the screen. The last one, if 2 planes intersect, the intersection is a line. That one's a little harder to see, but there's 2 planes. They intersect right there at that line. Let's do an example. Which postulate allows you to say that the intersection of a plane and the other plane is a line? So you can see in the picture, you have 2 planes. The intersection is this line right here. So how about if 2 planes intersect, they intersect in a line. That's the last one. Or you could say 2 planes intersect in a line. You're welcome to use your own words as long as it has the same meaning. Let's try another one. All right, let's write examples of the first 3 postulates from this lesson. All right, so looking at our picture, the first one is 2 points make a line. So in our picture, here's a line, and I have 2 points. So how about this? Line N passes through, what are the 2 points on line N? A and B. The second one is that a line contains at least 2 points. All right, line N contains which 2 points? A and B. The third one, if 2 lines intersect, the intersection is exactly 1 point. So 2 lines that intersect, all right, so lines N and M intersect at, what's the point they intersect at? A. There we go. We have now illustrated 3 of the postulates. In diagrams, you can assume certain things. All points shown are coplanar. If there's no plane drawn, assume they're all on the same plane. In this picture, we can assume linear pairs. AHB and BHD are linear pairs. We can also assume vertical angles. If the points are drawn on a line, assume they are collinear, but that's if a line is shown. You can assume intersections. If they cross, they actually cross. Things you cannot assume. You cannot assume collinear if there is no line. You can only assume collinear if there is a line drawn. You cannot assume intersections if they are not shown. B, F, and CE are not shown to intersect. You can also not assume that they don't intersect. They may later. You cannot assume congruent unless it is stated. You cannot assume perpendicular unless it is stated. And you cannot assume 90-degree angles, right angles, unless it is stated. They must have the right angle symbol for both of those. You must have the little congruent marks for the congruent. All right, so let's sketch a diagram showing ray FH perpendicular to EG at its midpoint M. So which one has the midpoint? Well, it has to be EG because a ray goes on forever. It can't have a midpoint. So here's a segment EG and its midpoint M. Well, how do I show it's the midpoint? Well, I have to show that the 2 sides are congruent. And then I have a ray FH, and it needs to be perpendicular. So it starts at F, goes through H, and to show it's perpendicular, we need the right angle mark. So that's the perpendicular. The congruent marks mean it's the midpoint. All right, let's try a few more. Which of the following cannot be assumed? We'll just do these true and false. A, B, C is collinear. Yes, they appear to be on the same line. They are marked as being on the same line. By the way, the dotted, like between B and C, that indicates it's just behind the plane and you can't see it. Line EF is perpendicular to line L. So here's EF, line L, and yes, it does have the perpendicular mark. Line BC is perpendicular to plane R. Here's line BC, but there's no right angle mark between that and R, so it is false. EF intersects AB, AC at B. Sure. Line L is perpendicular to line AB. Problem with that is, let me erase stuff. Problem with that is that there is no perpendicular mark between them. That perpendicular goes to line EF, not AB. And lastly, points B, C, and X are collinear. That's false because X is not on the same line. It's not drawn there, so it's false. So it was what? True and false and true and false and false. All right, so there is our summary. Have a good day.